This problem involves token-based processing. We're asked to write a method called check_sum that takes as a parameter a scanner containing a series of integers and that determines whether or not the sum starting from the first number is ever negative. So we have a couple of examples here. We're supposed to be computing 38 and then 38 plus 4 and then 38 plus 4 plus 19 and then 38 plus 4 plus 19 plus negative 27, all of those various sums, and we're supposed to see if any of those are negative. In this first case, even though we have some negative numbers in the middle, we never end up with a negative sum, so we report that fact. In the second case, what we find is that after adding 6 of these numbers together, we have a sum of negative 6, so we report that fact. And there's also a note here that we were supposed to report the first negative sum and that we're supposed to stop consuming input once we find such a negative sum. I've set up a JGrasp file that has these two examples. I've set them up as strings that I pass to a scanner constructor to make two scanner objects, and then I pass those scanners to our method that we're supposed to write, the check_sum method. This is a variation on cumulative sum. So it's a good thing to start with the cumulative sum code itself. So we want to initialize a sum variable to be 0 and then some kind of a loop. While there's more to be processed, we want to keep going. We're using a scanner here called input, and we're going to be reading it one number at a time by calling the nextInt method. So the test we want to use here is to ask the scanner whether it has a nextInt. So as long as the scanner reports that it has a nextInt, as long as there's another one of these in the scanner to be read, we can go ahead and read it in. So we can set a variable next to be what we get by asking the scanner to give us the nextInt, and then using that variable next, we can update our sum. So this is pretty classic cumulative sum code, and for now we can just report the sum that we find. We can say that that sum was whatever we found. So this is not the problem we were asked to solve, but it's a good starting point for getting the code that we're supposed to write. So let's go ahead and compile this, and then we'll run it and see what we get. And what we find is that that first sequence of numbers adds up to 77. That second sequence of numbers adds up to 151. Notice that that second sequence adds up to a number that isn't negative. Remember that we're supposed to be computing partial sums. So what the sample output indicated was that when you add the first 6 of these numbers together, you get a sum of negative 6. So we're not supposed to add all the way to the end, where we end up getting a sum that's not negative. Once we see that sum of negative 6, we're supposed to stop. And that's actually what makes this problem rather tricky, is figuring out how to deal with that. So what we want to do is to enhance our code to deal with that case where the sum goes negative. This line of the code is the one that's computing the various sums. Each time we've read in a new number, we compute a new sum that includes that number we just read in. So this is a logical place to have some kind of test that says if the sum has just gone negative, if that new sum we just computed is negative, then do whatever is appropriate for a negative sum. What are we supposed to do when we see a negative sum? We're actually supposed to do quite a few things. We're supposed to report that we've seen a negative sum. We're supposed to show what the sum was. And we're supposed to stop this loop from going. So a whole lot of stuff to do. So you might imagine that this is going to have a whole lot of lines of code here. But that gets kind of tricky to write the code in that way. So this is a nice place to use a Boolean flag. So what we can say is, let's set up a Boolean variable called found that will keep track of whether or not we found a negative sum. Initially we have not. We set found to be false. We have not found a negative sum here. And then what we can do inside of this if is a very simple line of code. We can set our flag to be true. So this is a classic use of a flag. We initialize it to false, but when we see a certain thing happen, we remember it. We remember that we saw a negative number. So that's the basic use of our flag. And that way, by setting it up in a variable, we have that variable available to us in other parts of the code. So for example, after the loop, we can say if we found a negative sum, we can do whatever's appropriate in that case. Well, when we find a negative sum, we're supposed to produce two lines of output. One of them says negative sum after a certain number of steps, and the other one reports the sum. So we can do a system.out.println negative sum after a certain number of steps. And then we're also supposed to print out the sum, just like we were doing a second ago. So that's what we're supposed to do in the case that we found a negative sum. If we have not found a negative sum, that's our other case, and we're supposed to report no negative sum in that case. So that can be just a simple system.out.println no negative sum. This isn't quite right, but again, it's getting closer. So let's go ahead and compile this version of it and run it and see what we get. The good news is that we have two different kinds of output. So it's correctly saying no negative sum for that first case that has that no negative sum is achieved. The second case, our flag is working in that it's recognizing that there was a negative sum there, but it's reporting the overall sum, the 151 sum, when we wanted it to report the sum of those first 6 numbers, the one that became a negative number. So we have to report how many steps it took, and we're supposed to report that sum as -6 rather than the sum of 151. So we want to stop this loop of ours from executing once it has found a negative sum. One way to do that is to use a break. That's a little bit sloppy. I mean, it can be done in that way. But with our Boolean flag, we have a much nicer alternative that we can make it part of the test. So this test says right now that the only thing we care about is that there's more input. Well, that's why it's reading all the way to the end, because it says keep reading as long as there's more input. So we want to have an extra condition here. We want to say and something is true. Well, we can't say and found. You know, we want to use our flag, but actually using it in this way is not the right way to do it, because we want to keep going when found is false. So we want to say while we haven't found something, we want to keep going. So not when we found something, but while we haven't found something, we want to keep going. So it has the kind of the opposite meaning of what our flag does. And so this is a very nice case to use the negation operator, the Boolean negation operator. What we're saying here in our while loop test is that we want to make sure that two things are true. We want to make sure that there is another integer to read, and we want to make sure that we have not yet found a negative sum. So looked at another way, there are two reasons for us to stop this loop. If we run out of numbers, we're going to stop the loop, or if found has become true, if this line of code has been executed, then we would no longer meet this condition. So either of those things would cause us to break out of this loop, either that we've run out of numbers or that found has now become true. So this should stop our loop from executing when it finds that negative sum. Let's take a look and run it. And now it's properly reporting that sum of -6. So it has apparently stopped at the right point. But we still have to fill in this detail. We're supposed to show how many steps it took. How many numbers did it add together before it found that? Well, this is a simple counting task. So we can just add a counter variable here. We would initialize our counter to be 0. We're counting how many numbers we read in. So we can have a line of code here, count plus plus. Every time we read one of these numbers, we'll increment our counter. And that way, in our println here, we can report that it was count steps when we saw that negative sum. So if we compile and run one more time, we can see that now we're getting the output we were supposed to produce. No negative sum in the first case, negative sum after 6 steps with a sum of -6 in that second case. And we might want to have a few more test cases than this, but in fact the code that we have here turns out to be a solution to the problem that we were asked to solve.